Good morning, good afternoon, good evening. Thank you for joining the webinar. Today we have 2018 Elevate Partner of the Year, Peer Software, joining Nutanix as they talk about ActiveActive File Services for Nutanix Enterprise Cloud. For your speakers today, we have Dwayne LaFlotte, CTO at Peer Software. And on the Nutanix side, we have Mike McGee, Senior Technical Marketing Engineer. If you have any questions during the presentation, please feel free to ask them in the chat box, and we'll give you an answer at the end. On your right-hand side, you can also find a link to our joint solution brief, as well as a PDF of the presentation. And at the end of this webcast as well, you will also receive a recording of the presentation. So with that, I'm going to pass that off to Mike. Mike, it's all yours.
No, thank you so much for the introduction. Hi, everyone. Thanks for joining. What I'd like to do is just to start off is just to step us through AFS at a high level, so you guys get a good understanding of Nutanix AFS as a core offering with Nutanix. But the majority of this presentation, I think, the real meat and what you're here to learn is about our friends at Peer. So I'm going to move through this quickly and then go ahead and turn it over to Dwayne. So just to level set, so everyone has an understanding, AFS is a software-defined file service that Nutanix offers on top of our existing solution. So whether you're an existing customer today that's running either ESXi or AHV as the underlying hypervisor, you can really deploy AFS at any time. It's included with our Ultimate Edition licensing, so if you're an Ultimate Edition customer today, you can go ahead and deploy it on existing infrastructure. We also have customers that like to do standalone instances as well, so if you have dedicated hardware and would like to run AFS there, you can do that also. The key things here is it's super easy to deploy and manage. It's built into the same interfaces that you may or may not be familiar with Nutanix today. Generally speaking, you're going to manage it from our Prism interface, which again, the same way you'd manage everything else in the environment. It's comprised with a set of file server virtual machines. So essentially what you're going to do is on that Nutanix hardware on top of our Acropolis operating system, you'll instantiate a set of virtual machines, and with those virtual machines, they'll form a file server cluster and a single namespace. We can start as small as 3 file servers today and grow to as much as 16 on that underlying hardware. So it's very much a software-defined, scale-out file server solution. You can even have multiple file server instances on the same hardware, so you're not tied to specific hardware limits in that space. If you had different authentication requirements, different networking requirements, etc. When it comes to deploying file shares themselves, we'll automatically load balance those shares across those file server VMs. And when you think about how Peer is going to do replication, they're going to be doing replication at the folder or the share level. So just to give you some background on how we distribute users and how we are performant and scale out with the workload, we have something called a home share. And when you create a home share, we'll automatically balance users across the file server VMs within that share. And we do it based on the concept of a top-level directory or TLD. So as you create top-level directories, we'll allocate them on certain file server VMs from a storage perspective, but we'll also do that from a front-end user connectivity perspective. So without you doing anything in the background on where users should live or with respect to performance, we'll go ahead and load balance those users nicely across those various file server VMs. We also have a construct called a general share. And with a general share, we'll place a general share individually on a given file server VM. So as you create general shares, each will be owned directly by one of those file server VMs within that particular cluster. So if you're going to deploy AFS and use it in conjunction with Peer, it's good to understand how those are balanced across the file server VMs as you create them, or as it's done automatically to help balance the environment. If you do happen to run into a bottleneck, again, being software defined, we're very agile in removing hotspots. So we have several performance optimizations that we'll do automatically under the covers. It will actually alert you and you can go ahead and execute it. So for example, if you created a bunch of shares and it led to an imbalance, we can move those shares around. So say in this instance, if file server VM2 became hot because of a certain share, we can actually move that share and those users over to another file server VM. Again, we'll alert you automatically, and all you have to do is click a button and it'll go ahead and do that for you. Further, if it's a larger physical cluster and you want to scale out the solution, say you know you're adding a bunch of users in the not too distant future and you want to make sure that they have the compute power within that file server cluster, we can automatically scale out. So add users, maybe it creates a hotspot, go ahead and allocate a brand new file server VM, and we'll automatically move those users over and make sure it scales out and performs very well. And further, in smaller environments, we can actually scale up automatically and on the fly. So if you, again, add additional users and can't scale out, we can hot plug CPU and memory into these file server VMs to help alleviate any hotspots. Again, helping with performance as you scale and as you grow. And lastly, on the top of HA, as you can imagine, everything is highly available within the system. If you were to have a failure in the environment, if a file server VM were to go offline, its underlying storage as well as its user connectivity will automatically migrate to one of the file server VMs that remain online, and users can continue to operate as they would otherwise. So high availability baked into the solution as a part of the deployment, nothing you need to worry about to configure on your own. As a part of our overall solution, we have various APIs and underlying partner integrated solutions around backup, as well as file operations monitoring. So we have a separate API built in so that partners that may do certain things like auditing can understand when a file was created, when it was deleted, open, closed, etc. You can actually see a list of those operations on the screen here. Well, our friends at Peer, they integrated with this API in order to get file operations and notifications to know what to do with respect to file locking and also replication. So on that note, I'm going to turn it over to Dwayne to dig into some of the details on how Peer leverages this API with their solution.
Awesome. Thanks, Mike. Appreciate it. So as was stated, my name is Dwayne LaFlotte. I'm the CTO here at Peer Software, and I'll go over, why is Peer a part of this solution? How do we help extend what some of the great things that AFS can already do today? And how do we give you that reach to do that globally? So some of the things that Peer has done for the last 25 years is deal with unstructured data. So that's the sole purpose of our company, is making sure that unstructured data is in the right place at the right time, whether that's high availability, which we'll talk about here today, whether that's for collaboration purposes, or whether that's for making sure that the data can be reached in either low bandwidth sites or remote branch offices. So we're kind of the unstructured data experts, and that's what we do, and that's why it's been a great partnership with the AFS team here at Nutanix. So some of the key things that customers today are looking to use AFS coupled with Peer. And we're going to break into these scenarios in a lot more depth throughout the course of this webinar. But at a high level, active global file sharing and collaboration. So as Mike had pointed out, AFS does a really great job of high availability of data inside the AFS cluster. So if any one of the file VMs goes down, it doesn't necessarily matter. Your data is still going to be available. Users are still going to be able to access it. But what if you also wanted to spread that high availability, not just within that cluster, but across the world? So if I had AFS clusters in London, in Munich, in New York, in LA, and I wanted to make sure that all of the unstructured data that exists on each of those clusters, each of those shares, is available everywhere. And if one of those were to go down, automatically my users would then just switch over to an available cluster and they would have access to their data. So that's what we'll talk about with this top ActiveActive file sharing and collaboration. The other thing that once we realize that we need to replicate this data around globally, and as multiple users are accessing this is a general purpose share, not quite a home share, you also want to layer locking on top of it to have a transactional file system, if you will, where if a file is opened in one location, it's locked everywhere else. So we'll talk about how that works with collaboration. We'll then go into ActiveActive for VDI and load balancing. So how exactly am I going to, when I have my VDI infrastructure and users are logging in and using VDI, There's a lot of unstructured data that deals with VDI, whether that's the user's home directory, whether that's the user's My Documents, pictures, even their desktop or profile information. A lot of that stuff is very convenient to sit right on top of the AFS cluster that's sitting there managing VDI. But now let's say I want to have high availability for VDI, where if for some reason users can't access the VDI instance that's sitting on the native cluster they have on site, they'll just automatically get redirected to another VDI instance at another site. Well, you need to make sure that their AFS data makes it there as well, their My Documents and profiles, etc. So I'm going to show you how Peer would do that as well and help you replicate that data around. Then finally, we've realized that there's a lot of different platforms out there. So how do you, in essence, get the data off of those platforms and move it over to AFS? And in the interim, while your storage infrastructure is aging out, how can you integrate your existing environment in AFS? How can I make the environments work well together? So I'll show you how we do that as well. That being said, let's start with our first scenario, which is active-active global file sharing and collaboration. So let's say in this particular situation, I have 3 different sites. So I have Munich, Washington, and Los Angeles. You'll notice here I have a Nutanix installation in each of those sites. And in each of those sites, I also have an AFS cluster. Now, I might be housing general purpose shares here. So in this particular case, maybe we're talking about an engineering share, a sales share, whatever it may be. So I have a general purpose share that multiple people may be working on at the same time. I want that data to be available in all locations. I want users in those locations to have fast access to the data, so I don't want them reaching over the WAN unless they need to grab information. But I also want consistency. I need a layer of a transactional file system, if you will, on top of this to make sure that there aren't a lot of conflicts and overwrites, etc., so that users can work well together. This is where Peer may come into play. Peer is a software solution. So all we're doing is we are software that sits on top of Windows VM that's sitting inside of AHV, and we're running and monitoring AFS. Like Mike had pointed out, AFS has an interface, the File Operations Monitor and File Activity Monitoring API, that gives us an understanding of reads, writes, deletes, permission changes, etc. So as users change data on AFS or applications, we see that in real time, and we have the ability to act on that. One of the key things I like to point out is you will notice that as users are reading and writing, so I'm going to move this forward here. Hopefully we'll see a user. There we go. So as users access data and they're reading and writing to the AFS shares that are presented, those users are literally writing to AFS. They're not writing through our software. So our software is not in band. Our software is asynchronous. We're getting notified via AFS in real time what's going on, and then we're performing those operations remotely. What typically customers will do is they'll layer on top of this some form of namespace. So in this particular example, I've put in DFSN, so DFS namespace, where if any of my users in the organization go to //company.com/departments, they're going to be redirected to whatever the closest AFS cluster is that responds the quickest to them, and they're going to be able to see their data. The redirector is nice because if there is an issue with a particular cluster or access to a particular cluster, doesn't matter. The users are redirected to another cluster, so we'll see that in a second. Now, do you have to use DFS namespace? You do not. You could use all sorts of technologies out there. I know there's plenty of load balancing technologies like F5 that can redirect users at the SMB layer to appropriate shares based on speed and bandwidth. Whatever technologies that you guys already have in place on site is compatible with this, as we're not in the middle of the path of the user accessing the share. So whatever technologies you'd use to load balance shares in normal, you could use here as well. Now, as we have our users at each site, each of these users, let's say in Munich, my user goes to access that share. So my user goes to //company.com/departments, and the redirector, the DFS, in this case, DFS name redirector, points them at the share that's sitting on the AFS cluster in Munich, because that's the quickest one that's highly available and up right now. Now that user then, once they have access to that share, decides, well, I want to create a document, right? So I'm going to put a sales brief out in this particular directory. When that happens, you'll notice AFS is now notifying that local peer agent that this file has been created in this location. We then replicate that data out to our hub. So we have a broker. Our replication model is hub and spoke. The reason we do hub and spoke is it's multiple fold. It's much more efficient for us to replicate data to multiple locations as a hub and spoke, because if not, you have to do a mesh replication. There's all sorts of issues with mesh replications. So with hub and spoke, we can very easily notify one sort of master broker that can be highly available as to the fact that this file has changed and is new in this particular location. That hub then has control over the remaining agents in the environment. So you'll notice here, the hub agent, or the agent in Washington and the agent in Los Angeles, have checked in with the hub and they realize that there's a new document for them to pull down, so they're going to pull that document down. That document is then persisted down to the local AFS in both of those locations. But remember, I said this is a general purpose share, so I want locking on top of this as well. So in this particular case, that file now is consistent in that in Munich, the user still has that file open and might be making changes. And the file in the other two locations is locked, even though it's there and it's read-only. So users can still open that file, can still see that file. And even if we're doing, let's say you're doing auto-saves at the Word document, right? They'll see the latest saves of those files at the remote locations because we're continually replicating it. But they're not able to make changes to it unless that primary user closes the file. So as this user closes the file in Munich, we'll see that change gets replicated. Obviously, the change happens out on AFS. But we see that change out on AFS over in Munich, and at the byte level, we replicate that data over to the hub or to the broker. It's key that I say the byte level. Reason being is, let's say I have a 100 meg video file and somebody just annotates the first couple of seconds of that file. Maybe that's only 200K worth of change. Well, I don't want to replicate the whole 100 meg file out. I only want to replicate the 200K. That's what's happening here behind the scenes. So we have a highly efficient byte level replication that is also encrypted, 256-bit AES encryption using SSL. So this is an encrypted chain replicated out to that broker. That broker then will replicate those byte level changes down to each of the agents, which will then persist them to their local AFS clusters. And then from there, the lock will be released because the file is now consistent. The file transactionally across the organization is exactly the same. And now anybody has access to that file to open it in a normal capacity. Now let's say disaster happens. For some reason, the users in Munich do not have access to the AFS cluster in Munich. Whether that's the cluster's down, maybe the cluster is being patched, maybe somebody went over to the data center and shut off all the power, whatever it may be. When the users from Munich try and access the DFS namespace, or however you're load balancing that share, what will happen is the redirector will say, okay, well, the closest potential and fastest responding AFS share is over here in Los Angeles. So now as that user in Munich goes to access data, they're just accessing it in Los Angeles, and LA already has all the latest data because Peer's replicated at the byte level. So the user has the ability to do reads and writes and make changes and do whatever that user would normally do. When those changes happen, the local AFS cluster in Los Angeles notifies the broker, and the broker then will replicate that out to Washington, D.C. So you're still up in a production capacity and highly available. Users still have access in both locations, and even in Munich, users are redirected to the quickest available location, and that data continues to replicate. Nothing needs to be done in the background. So you're not going in and managing anything. You don't need to change any settings. This just all happens automatically. Now, as the files continue to change, let's say, for example, the AFS cluster in Munich finally comes back up. For whatever reason it was down, somebody goes and turns on the power to the data center and everything comes and lights back up. What will happen is Peer will register with that local AFS cluster, will understand what it needs for changes from that broker. So it's going to reach out to the broker and say, hey, listen, I was offline for a period of time. What's changed? And that broker is going to say, okay, well, here are all of the file data that you need from the other locations. It's going to pull that information, and then it's going to go right back into continuous synchronization. So you don't need to worry about that cluster being offline. Everything automatically is going to come right back online and go right back into a synchronization mode. And by all means, like Aaron had pointed out, there is a questions section as well. So if you guys do have questions, just let us know, and we'll answer those throughout the presentation here. So the next thing I want to move into is ActiveActive continuous availability for load balancing and high availability for VDI. So VDI is a great space, a very fast-moving space right now, and a great growth space for most organizations. It's a good way to leverage a lot of the existing hardware that you may have, and a great, one of the things that Nutanix excels at quite a bit. So here you can see I have a typical sort of VDI implementation. Maybe I have a Nutanix cluster sitting in Los Angeles, another one sitting in Washington, D.C. You'll notice that the replication paradigm looks a little bit different here because I don't have 3 sites, but it is in essence the same. I have an agent reporting to that broker in Los Angeles, and I have a Washington, D.C. I have another agent reporting to the broker. If I had 10 VDI sites, 20 VDI sites, 200 VDI sites, be the same thing. I would have an agent sitting on a Windows VM at each site. It would be registered with AFS for that file activity monitoring API, and then we would be reporting into that broker, so that broker would know all of the changes that happen in real time. So let's say, for example, my user over here in Los Angeles logs into VDI, gets their normal profile and all of their attached information, whether it's going to be their My Documents or their My Pictures or their desktop or wherever it might be, part of their profile, is sitting right there on that local AFS cluster, which is really convenient, right? I have a file system right there that's highly scalable, gives me the ability to manage all of that data and a lot of ops per second, and I don't need to worry about having other platforms house that. So here I have that information right there. That's fine. And that agent is monitoring that AFS location. Now, interestingly enough, because this is and we see here 2 other users just logging into the Washington, D.C. site like normal, same type of thing is going to happen. They're going to have access to their, whether it's My Documents or et cetera, their home drives, and that information is going to be monitored by that local agent. As changes happen throughout the organization, you'll notice, for example, the replication that's going back and forth here looks similar. One of the things we do change when we start talking about VDI is, in general, we're going to shut off locking. So there's a lot of granular policy settings that you can set depending on the nature of what you're replicating. In this particular case, the users themselves, as they're accessing their VDI instances, there's no need for them to have global locking because it's not like they're going to be accessing those instances at the same exact time in multiple locations trying to access the same exact file. Usually the user's hitting one VDI instance, and then if that one goes down or they happen to travel to another location, they're accessing another one. In this particular case, whether the VDI instance that's sitting in Los Angeles here, let's say potentially goes down, there's an issue there. We want that user to have high availability of their VDI instance. So in this case, they can actually, when they go to log in to their VDI, automatically what's going to happen is they're going to reach whatever the next highly available VDI instance is. And in this case, it's the Washington, D.C. instance. Now, if this user's data wasn't replicated from AFS over, their My Documents and profile, et cetera, then they wouldn't have access to all their information. However, because Peer continually was monitoring and replicating that data over, that user just attaches to the local AFS cluster and has access to their home drive just like normal. And they can make changes and do whatever they want to do. As that instance that then is in Los Angeles, let's say, comes back online, automatically the agent in Los Angeles will detect that. It will pull over the changes from the AFS instance that's sitting in DC. And then the next time that user goes to log into their instance, they're going to get their normal connection right back to that local AFS cluster in Los Angeles. So this gives you the ability, you've already had with Nutanix a great ability to have high availability of VDI prior to this, but now you also have the ability to couple that with the AFS cluster replication and high availability of that as well, spread globally. So I could have that here. I have it Los Angeles and Washington, D.C., but these could be anywhere in the world. The next thing we want to talk about is how do we then extend reach, right? So the data centers that we have today obviously aren't necessarily 100% pure Nutanix right now. So as your other platforms age out and you're looking to replace them with Nutanix and Nutanix AFS, how could we do that in a seamless way? How can we make that as easy as possible to do? And how can we do that with the least amount of disruptions to the end users? And that's what this sort of section is about. So here what you'll notice is, although we do have the connector into the Nutanix AFS, which is that file operations monitor connection, which allows us to see reads and writes and deletes and permission changes and that sort of stuff. Peer's been around, like I said, for 25 years. So we also do have those same monitoring APIs for other pieces of hardware and storage devices you may have already in your environment, whether that's a Windows server with iSCSI or SAN attached or direct attached storage, whether that's a NetApp filer, could be an SVM that's sitting in the cloud, it could be a NetApp that's on-prem, could be Isilon, VNX, could be IaaS, right, infrastructure as a service, just VMs running in the cloud. So as for a software layer, you can actually create and install those agents to monitor existing platforms today. So let's say you have Nutanix and you want to create an AFS share where I can pull all of my repository of information over to and start leveraging that in a particular site. You can now have the ability to put that in one site if you want to and continue replicating with other storage devices you have today. So seamlessly, for example, if someone were to open a file in this particular example, you'll see I have multiple locations. I have a Cloud ONTAP sitting up in Azure. I have my Miami office has maybe an EMC Isilon. You'll see I have my Munich office over here. It just has Windows Server. I have IaaS sitting up in Western Azure region. And then I also have in Washington, D.C., I have my AFS implementation. So in this particular situation, let's say an end user were to open a file on the Isilon, or an end user were to open a file on the Windows server that's sitting in Munich. We will globally lock that file everywhere in all of the locations that are shown on this slide deck. And then as that user makes changes, when they close that document or auto saves, at the byte level, I'm going to replicate that data amongst all of the different storage devices here, and then release the lock once that document changes. So you have that transactional file system that now can layer on top of existing storage devices you have today, allowing you to then replace and move forward a lot quicker using AFS in the future. Now, one of the other synchronization possibilities, because we see everything in real time, we also do have the ability with our Analytics Ready replication to replicate up into Azure Blob. So this is another feature that now you would have the ability to do immediately today on AFS, and as well as any other existing platforms. So with AFS, what I can do is I can have my normal agent like we had before, and it's monitoring AFS over that file operations monitor. And from there, I see reads and writes and deletes, etc. But the replication is a little bit different in this case. What I'm doing is as I see files being created, deleted, permission changes, etc., I'm in real time replicating that data up to Azure Blob. From there, those files are actually transparent, what we like to call Analytic Ready. So what does Analytic Ready mean? Analytic Ready just means if I had a Word document that was sitting on AFS, when I replicate it up as a blob, it literally is still a Word document. So it's not encrypted, it's not compressed, it's not in any vault that's proprietary, right? Up in blob, it looks like a Word document. You could open it up like a Word document. What that gives you the ability to do is multiple things. First off, I can leverage the native sort of Azure capacity to do snapshots. So you'd get a simple ability to restore data if you needed to. So I could say, maybe 10 times a day, I want to take a snapshot. And then at any point in time, I can just right click and say, I want to recover a file from, 5 prior versions. So I can do that. But what you also have the ability to do is layer on top of this any of the other services that Azure has. And that might be machine learning. That might be artificial intelligence. That could be cognitive services. So to give you quick examples of where we're seeing customers leverage this today, we have customers doing things like facial recognition, where I'm pumping lots of images up to my AFS shares. And as I see those images, I'm replicating those images up to Azure and kicking off cognitive services to look for certain people, right? So for example, that might be, maybe I'm pushing images of customers coming into a store and I'm looking for known shoplifters, right? So that's something that we're working with customers on with this Cloud Sync technology. We have other customers that are call centers, right? Where, people are calling in for support for a particular thing, and those calls are recorded. Well, they're recorded as an MP3 file and put on the AFS cluster. At that point, as we see those, we can pick those up automatically, upload them up into Azure, kick off something like cognitive services. Cognitive services then can go through and pick up sentiment analysis, right? Are these people angry when they're calling? Are they happy when they're calling, right? And we can get real-time feedback on those calls. We have other customers that are doing things. We have a mining company we're dealing with that's taking video files of miners entering and leaving mines. And as those video files are taken, as they're dropped on an AFS cluster, they can be picked up and pushed up into Azure. And at that point, we can do object analysis. Are the miners wearing hard hats? Are they wearing boots? Do they have the proper safety equipment? So all of these are examples of things that are being done inside of Azure Cognitive Services. And there's a whole host of other things with machine learning and artificial intelligence that you could do as well, but these are just some sort of simple examples. One of the other things is, well, what if now I have an environment where I may have Windows or Isilon or VNX or NetApp, and now what I want to do is I want to migrate off of those. So maybe it's my refresh cycle, and this is probably a good place to sort of talk about a joint customer that Nutanix and Peer have together. I can't mention their name, unfortunately, but they're in the top 10 of financials. So they're a pretty large customer. And what they were trying to do is they were talking about, listen, we have this large project where we really need VDI to be replicated around the world, highly available. We have executives that fly around the world, and when they open up their laptop and connect into their VDI, their data should be A, fast and in the local location where they're at. B, should be highly available. So if that local location does have an issue, they can just automatically redirect and have access to not only the VDI instance, but also have access to all of their home directory information. And third, we have an existing environment right now, which is a NetApp environment. So what we want to do is drag all that information off of NetApp, so all of the home directories, et cetera, pull that information over to AFS, and then set up this VDI sitting right on top of Nutanix. And this is where the two solutions pair very well together. Because in this particular case, all of the different sites that had NetApp, the first thing we needed to do was seamlessly migrate the data over to AFS, while at the same time also create VDI instance sitting on Nutanix. So the VDI instances were created on Nutanix. The VDI instances for their home directories and My Documents and all that good stuff could point out at the existing NetApp filers. Peer was monitoring those NetApp filers, those SVMs. So as we see reads and writes and deletes and changes, et cetera, we're replicating that in a unidirectional way. We're replicating it one way out to the AFS cluster. At any point in time, all you need to do is repoint those locations out to the AFS cluster, and now you're done. So one of the problems would normally happen when you run into a migration is the fact that, well, first thing you need to do is scan and understand what's on the primary tier storage. Then you need to migrate it to the new storage. In this case, would be AFS. Then you need to run that migration. You're obviously going to run into issues and locked files and all that good stuff. So what you need to do is kick the users off the primary tier, run an entire scan again, which on petabytes of storage or even hundreds of terabytes of storage may take days while users don't have access to that primary tier of storage. So with this solution, you don't run into that issue because as we're monitoring in real time, we're in real time making those changes out to the AFS cluster. So the repoint of the users to the new storage is instant and seamless for them. So this gives you an easy on-ramp to pull information over to AFS in a very simple way and in a way that's not going to affect end users' day-to-day business. And in this case, they're pretty large financial. Their day-to-day business represents quite a bit of money. So they were very interested in having a zero downtime cutover for VDI over to AFS. With that, I mean, that's all of the sort of high-level architecture. By all means, if you guys have any questions, we can go into how all the bits and bytes work and that sort of stuff. But we really like to thank you for attending the webinar. We do have a link here, peersoftware.com/go-Nutanix. So if you want to pull down more information, as well as I know Aaron's going to have links here for you to pull down information there as well. And with that, Aaron, I will turn it right back over to you.
Thank you so much, Dwayne. Yeah, so like Glenn was saying, we have a joint solution brief on the right side, as well as a link to the presentation. At the end of the webinar, you will receive a replay. And we'll give a minute or a second for any questions that come in.
And while we wait for those, if you don't mind, Aaron,
yeah,
I can jump in and answer some normal sort of standard questions we got. So a lot of customers ask us, okay, so this is real-time active collaboration, and I have the ability to do this spread across the world. Sounds magical, but is there any chance of conflicts? So let's say two users, and I've had this situation happen. I had one user in Mumbai and another user in LA, and they both called each other on the phone, and they counted down from 3 to 1, and they both double-clicked on the same file, but at their local AFS implementations. And sure enough, they both can open the file, and it doesn't get locked. Why? Because quantum networks aren't really available yet, so instant replication and notification to the other side doesn't happen that quick. But even if these types of situations happen, you're never going to experience data loss. Reason being is users make changes. Let's say even both those users make changes to that file and save it and close it. Our replication engine is smart enough to realize that those files were outside of the maintained transactional file system, and we're going to kick them out of the replication, and we're going to send a notification saying, hey, this file, for some reason, in this case, these two users clicked on it literally at the same time, were changed outside of the management that we could maintain. And we're going to kick out a notification saying, you have to merge the file. Once the users merge that file, we bring it right back into the replication set. So the fear of losing data isn't there as well. Not something that we need to worry about.
Awesome.
So here I see a question, what is the footprint? So the footprint of the agents itself is actually quite small because all it's doing is monitoring real-time activity. So typically, it'll run in about 2 gig of RAM. Typically, it requires about a 200 to 300 meg of hard drive space. And typically, we recommend 2 CPUs for it to run. But it's usually only running a couple percentages of those. The reason we say 2 CPUs is because we have the ability to split affinity of threads of replication. The more CPUs, the more affinity of threads we have and that sort of stuff. But that being said, the footprint is really tiny because we're not caching the files as we transmit them. The file sits on AFS, and we're leveraging AFS as a database of what's there. Right? So there's no need for us to, we don't have our own database. We don't have to maintain any information around that. We see what's on the AFS. We see in real time what changes, and we replicate those changes around. So those are pretty light. It was a good question.
Yeah, and I can give you the footprint from an AFS perspective too. So today we have 3 file server VMs, and the minimum configuration for those 3 file server VMs is 4 vCPU and 12 gigs of memory. And then depending on the number of user connections or throughput that you would want, we can increase that number from there. From a physical footprint perspective, you can put this on a 2U appliance. So from a data center, rack space, power cooling, and all that, 2U is all you would need for Nutanix, and you can put a 3-node physical cluster within that 2U. Now, before planned, so I'm going to give you a bit of a future, but it's planned within roadmap before the end of this calendar year, we're expecting a 1-node VM AFS solution. So instead of requiring 3, you can use 1, and that's targeted for our existing Robo solution, which can be either 1 physical node or 2 physical nodes. So on that 1 or 2 node system, you could have a single file server VM with similar CPU and memory as I just mentioned. So hopefully that gives you the complete footprint view.
All right. It looks like we don't have any more questions. So from all of us here at Nutanix and Peer Software, we'd like to thank you for joining. Thank you, Dwayne. Thank you, Mike. And I hope you all enjoy the rest of your evening, morning, or night, wherever you may be. Thank you.